This video is on Lewis structures and shape, and it's called valence shell electron repulsion theory. And essentially what that says is if you have any atom with electron groups, pairs of electrons or bonds to another atom, we know that these electrons here want to get as far away from each other as possible. All you have to do is, one, draw the Lewis dot structure, and then two, you have to determine the number of electron groups, and then three, put the electrons groups as far away from each other as possible. So let's try one. So the first one we're going to do is the simplest one. It will be an atom with two electron groups. So we're always looking at the central atom. The one I want to choose is CO2, the Lewis dot structure, which you should know how to do. And we count the number of, the first thing to do is count the number of electron groups. So I have one group here. This double bond is one group because these electrons cannot move. They're stuck between the carbon and the oxygen. Here is another electron group. And I didn't draw my outer electrons, which I'll put them in now. There's two here and two here and two here. I'm only interested in the shape about the central atom. I'm only interested in this shape, okay, about this central carbon atom. So two groups, for the electrons to get as far apart as possible from each other, they're going to be 180 degrees. The molecule is going to put an oxygen here and an oxygen here. If I did this, the electrons are closer to each other here. So these want to get as far apart as we can. So this is called a linear structure, and the bond angle, which we're going to abbreviate BA, is this angle here, which, if you should know your geometry, is 180 degrees. So it's linear, bond angle equal 180 degrees. The second type is going to be a couple different types. We're going to talk about a straightforward one, H2CO. And if I do the Lewis dot structure, we're going to look about the central atom. On the exams, I'll be very careful to tell you which atom's central. So it's the carbon atom that's central, and we count the number of groups. So I have one group here, I have an electron group here, and I have an electron group here. And once again, I forgot my other electron pairs on there. But I am only interested in the shape around here. So we have three groups, and so this is going to go into a domain of electrons, three groups, and these three groups are going to get as far away as possible from each other, which is why you've probably seen me draw it like this, because this is as far away as we can get from each other. Okay, remember, this double bond counts as one electron group. So three groups getting far away from each other is 360 degrees in a circle. 360 divided by 3 is 120 degrees. This is called, it has a special name, it's like a triangle, so we call it trigonal, and it's in the plane of the paper, planar. The bond angle is 120 degrees. That's all there is to it. Well, all you have to do to get this right is get the right Lewis dot structure. Let's do another one, SO3. SO3 has a Lewis dot structure that looks like this. Double bond O, bond O, bond O, and this time I'll put my electron pairs on here. I don't care about them. I only care about what's around the sulfur. And I have three electron groups, and 3 gets as far away from itself as it can, so the shape will be looking like that. And the bond angle will be 120 degrees. We would call this trigonal planar, and a bond angle of 120 degrees. All right, one more in this group. let's look at NO2 minus, which has this Lewis dot structure. Now, this is a little bit different because I have one electron group, two electron groups, and a non-bonded for 3. So this is still in a, it's called a domain of 3 electron groups. That puts it in this type of structure. And I'm going to have an O, I'm going to have an oxygen, and I'm going to have an electron pair. This is not a Lewis dot structure. I'm just drawing this blue line right here so that I can see where the electron pair is. And that this electron pair takes up space, as does this one and this one. And so I have 3 electron groups around it. That is trigonal planar domain, but the shape is only the shape of the atoms. So the shape is going to look like this, and we have a special name for that. It's called bent. Remember, we do not name these electrons up here in the shape name, but they help determine the shape. So it's bent, and the bond angle equal 120. We're going to do another one real quick. Let's do SO2. Okay, 3 groups around. Group 1, Group 2, Group 3. So that's going to do exactly the same thing. I put my sulfur here. I can put an oxygen here. I can put an oxygen up here. And I can put an electron pair down here. If you want to double bond that, you can. We don't care because we're only interested in the shape. And so 3 electron groups, 1, 2, 3. That is trigonal planar domain, but the shape is the shape of the oxygen, sulfur, and oxygen. We do not name the electron pairs in the shape. So this is bent, and it's 120 degrees. Piece of cake. All right, we got the hard one to do now. 4 electron groups. And you may want to look online for this. I'll put some links in there to see shapes. But 4 electron groups is in 3 dimensions. So it goes into a sphere. This one is down and out of the plane of the paper. And so this is one bond here. Okay? And then we have one down and behind the paper. This one represents down and behind. This one represents down and in front. And these are hard to see. Okay? So we'll do some ones right now. There's only 4 of them. So we'll start with an easy one, CH4, Lewis dot structure. But when we put it in 3 dimensions, these hydrogens get farther apart than 90 degrees. So we have to draw this type of structure. And this is exaggerated. Now this is small and it gets bigger as we come out. These are not electron pairs here. Okay? They're just showing that the electron group is down and behind the plane of the paper. So I put my hydrogen on, a hydrogen here, and a hydrogen here, and this is called tetrahedral. Bond angle on these is 109.5. Okay? So CCl4 is exactly the same thing. If I can write it, CCl4. We draw the Lewis dot structure, carbon, 4 chlorines. Chlorine's hard because you sometimes think this is an electron pair, but it's just the symbol of the atom. You've got to be careful with that. Okay, so we're going to draw our general shape. Here it is, 4 domain. 1, 2, down, and down, down behind, down and in front, down and in the plane of the paper, and in the plane of the paper. And again, our bond angle between all chlorines is 109.5, and this is the tetrahedral domain, And it is tetrahedral because I have 4 electron groups in here, all with an atom. I am not going to make you name the name. You're only going to do the shapes of the atoms. Let's do another one. NH3, Lewis dot structure looks like this. And you should ask yourself immediately how many electron groups. 1, 2, 3, 4 electron groups. So when I draw this, I'll put it in this type of shape. You can just draw this immediately. You can exaggerate how much down. And then I put my atoms on this. And I'm going to put my electron pairs up here. If you have 1 electron pair, put it on the top. So this is in 4 groups. So it's in the tetrahedral domain. There they are, 1, 2, 3, 4. But the shape is determined by this part. And this is called trigonal because it looks like a triangle down here. Trigonal pyramidal. Or sometimes pyramidal. You'll see it both ways. I'll accept either on my exams. Okay? And so this one has 4 electron groups and an extra electron pair. All right, the last one is, well, let's do H2O. So the Lewis dot structure for H2O might look like this. And you ask yourself, how many electron groups on here? 1, 2, 3, 4. So I'm in the tetrahedral domain, but that's not what I'm going to do. I'm going to draw it first. There's my oxygen, and I'm going to put an electron. Oh, what did I do? That should have been an electron pair here. I'm going to put my electron pairs. When I have 2 electron pairs, I put them down here. It's easier to see, and then I can see this, and this is clearly bent with a bond angle of 109.5. So we call it bent. Sometimes you'll hear that called angular. I don't care. 109.5 for the bond angle. That's really it. If I take something like HCl, it has 4 electron groups around the chlorine. I have an H and Cl. But there's only 2 atoms. And so anytime you have 2 atoms, it's linear. I mean, I could do this. Put my electrons here, here. Put electrons here, and an H here. And this part would be linear. So you see that once in a while. So you'll have to draw Lewis dot structures, and you will have to figure out the number of electron groups, the electron domain. You will have to name the shape, and you will have to give the bond angle on the exam.